In this video, you will learn how to identify the number of protons, electrons, and neutrons in an atom. You know very well that all matter is composed of atoms. It is through the effort of the great scientists in physics and chemistry that the subatomic particles were discovered. There are some concepts you need to know first before we jump into the main topic. Number 1, an atom is composed of three subatomic particles: the proton, which is the positively charged subatomic particles. Next is the neutron, which is the neutrally charged particle or neutral, and the electron, which is the negatively charged. Number 2, the atomic number of an atom is equal to the number of protons. The number of protons is equivalent to the total number of electrons since the atom is electrically neutral. And number 3, the mass number. The atomic mass in whole number is equal to the number of protons and neutrons. Those things are very important. That's why there is a need for you to keep that in mind. This lesson necessitates you also to use your periodic table and your calculator. As for me, I have here my periodic table of elements, which we'll be using a little later, and my calculator here just in the desk. So let's have the element helium. So let's say, for example, you want to know the subatomic particles present in the element helium. Helium is symbolized by H and E. Now, there is a need for us to know the atomic number and atomic weight. So we need to use the periodic table of elements in order for us to get the atomic number and the atomic weight of these elements. So let's try to check our periodic table of elements here. Okay, we are looking for the element helium, and helium is actually found here. This is helium, and let's try to figure out information about helium. Now, if you don't have your app about periodic table of elements, you can use the printed form of periodic table of elements, though it's very small. That's the disadvantage. Well, this one, you can just see through it that the atomic number is actually here. The atomic number is 2, and the atomic weight is 4.0026. Since this is mass number, we will round it off, making the mass number as 4. So let's go back to our whiteboard. Helium has an atomic weight of 4 and atomic number of 2. So let me just rewrite it to make it clear. Helium has an atomic mass or mass number of 4 and atomic number of 2. So what does these information tells us? So let me erase this. Okay. So the number at the bottom part of the symbol is actually representing the atomic number. Let's go back to the concept I told you a while ago. Let's focus on number 2. The atomic number of an atom is equal to the number of protons. Let's go back to our board. Meaning to say, since the atomic number is 2, our number of protons is also 2. Let's go back again to the basic concepts. The number of protons is equivalent to the total number of electrons since the atom is electrically neutral. And that gives us also the number of electrons. The number of electrons will also be 2. Since the atom is electrically neutral, it has the same number of protons and electrons. Now, the next is, how do we get the number of neutrons? We will go back again to our basic concept. Number 3, the mass number is equal to the number of protons and neutrons. Since we now know the number of protons, it would be easier for us to calculate the number of neutrons. Okay, but how? We need to get the 4 here. And since we already know the number of proton is 2, then we just have to subtract 2 from 4, giving us the answer 2. And that means the number of neutrons for helium is 2. Very easy. Let's try another example. Let's try to solve for Na. And what does Na stands for? It's the element sodium. Let's try to figure out what is the number of electrons, protons, and neutrons for the element sodium. We need to go again to our periodic table of elements, and let's try to find out where is sodium. Sodium is in the first group of element here, and so let's try to figure out its atomic number and atomic mass. Its atomic number is 11, and its atomic weight is 22.9897, giving us the mass number of 23. Okay, so let's go back to our whiteboard and try to write the necessary information for the element sodium. On the top part, you are going to write there the mass number. So the mass number is 23. And at the bottom part, you are going to write there the atomic number, which is 11. So basically, the number of protons is equivalent to the atomic number. So the protons is 11. And since the atom is electrically neutral, that gives us the number of electrons to 11 also. To get the number of neutrons, subtract 11 from 23, that gives us 12. So the number of neutron for sodium is 12. So going back, the number of proton is equivalent to its atomic number. The number of proton is equivalent to the number of electron. And the neutron is the mass number subtracted by atomic number. That gives us now the protons. And that is how you solve for the subatomic particles of an element.